Oh wait, that should be easy though. Never mind. And then what's precipitate? It's like what's precipitate?
Precipitate is like the falling of light.
Yeah, no, but that's not what's in here. Okay, you know what? Whatever. So where's the copper nitrate?
Somewhere in there.
It's the blue.
Is it actually? Okay, so add. Do I take this off? Okay, good. I was gonna like. So add 1 drop of this into a well 1. I got this. Camera, you should probably leave the scene. No, I'll put it over here because you'll see. Okay, whatever. I'll put 1 drop in. Okay.
Wow, stellar.
2 drops in B. Oh, in B1. Okay.
Yeah.
Don't mess up.
All right, you have all
3
4
and
of your
C1.
chemicals. All bottles filled?
Yes.
1,
Good.
2,
The 90 well is one of the
and
smaller,
then 5 in the next one, I guess.
smaller ones.
1, 2, 3, 4. Oh, almost did 5. Okay, and then E1, 1, 2.
The 96 well is this one, the smaller ones.
5. Okay.
And there are plastic toothpicks in
So,
here
you guys can do the next
somewhere.
Oh, thanks.
Okay, so we need the Ki, which is potassium ion, and you add. Wait. No. It says add 5 drops of Ki to this well.
Oh yeah, 5.
So add 5 drops to this.
5, 4, 3, 2, 1.
Okay,
Yes.
5, 4, 3, 2, 1. I got you. Here we go. Look at me going. 2.
Okay. No. Whoa. You do a different one on that one. Oh wait, no you don't.
No, we do 4, 3,
Wait.
2, 1.
Add to. Oh, okay. I see that. I see
Find your
that.
plastic
I didn't read that. I thought it was different. I thought it was
before.
different things.
I thought yours were non-plastic, you would, but you better have plastic. Gonna get precipitate, so.
1, 2, 3.
Whoa, it's like darker
Are you
yellow.
to get 1 drop, or 2 or 3 or 4, how many drops you have in each one?
Come on.
We have plenty of these pipettes. Guys, don't
Okay,
mix
so now
it,
we
you
gotta
can't,
mix these solutions.
class, don't use this pipette for all 4. Use a different pipette for each one.
Oh, yeah,
Do
we're
the
gonna-
best you can clean them up afterwards, but, so if you do that, then if I do 1 drop, 2, 3, 4, and I have a little bit of throw, I can put it back in the bottle, and I'm okay.
Okay, now I gotta
So,
stir
you
these.
everybody can't stand
You
it.
rinse in between.
So is that what that beaker's for?
Yes.
Stirring.
I feel like it's about to explode.
Okay, do I need to take a towel for that?
Don't want any contamination.
Okay, and then use this one. It's so funny how the colors are now different for each
Oh,
one.
dang. Then we have to wait.
Yeah, then I have to wait like 5 minutes. So I'll set a timer.
Do you have an eraser on your pencil, Josh?
How could you not have an eraser on a pencil?
Because I wore it out, but they're still wet.
Then use another pencil. Oh, I see, it's
So you couldn't
mechanical.
find the plastic toothpicks, I know. We use them before, we use them.
Okay, so now we gotta let it sit for, I'm gonna say 5 to 10 minutes, so I'm gonna say like what?
7 minutes, 30 seconds.
It might have been used in the
Exactly.
It might have been, actually, I think.
It is
Big plastic, big plastic ones, the biology.
I'm not sick, I just gotta take a bath.
That's what they always say.
We're all gonna die.
Yep, exactly. We will.
Okay, so drop 1. So hold up.
It's 1, 2, 3, 4, 5, 5.
Yeah, here's got the toothpicks. It's biology. Okay, guys, here's some plastic toothpicks. Would you wash them off and return them to this when you're done? And then put it in I'll put it next to you so you know. Put it back in this kit for biology, and I'll find some for the other group, the same thing.
So,
Because they actually want me there as soon as I can today, because she's,
And then
Dr. wants.
we can go ahead and mix the other two.
Okay.
yeah, we want to do that? Okay.
Yeah.
Let's go ahead and do that.
So, do you want to do that, Josh? You're not, you're the only one that's not done that. You gotta get that, you gotta get that, yes.
I don't even know how to participate. Whatever. I can't talk.
Okay,
So what else? One drop of C8NO3, whatever that is. Calcium.
And,
There's calcium nitrate. One drop to what? 12. C12. So one.
So this didn't have it.
Did I put two?
let's go ahead.
I think that was fine.
And then two, and so on and so forth.
2, 3.
That was close. 1, 2.
Okay, gentlemen, we have,
Work? Okay.
this is the toothpicks, there's 2 or 3 hard
yeah.
plastic toothpicks you can
We
use.
found one too.
Oh, you did? Is that what you're using?
Yes, sir.
Okay. When you're done, would you clean it off, put it back in here,
Sure.
put it in here?
Yes.
So that's good. Did you lend them one of the toothpicks or what?
We found it in our kit.
It was in a
It's in your kit, okay.
Surprise!
But you can wash off and
Okay,
get it
so
in the kit then, don't worry about it. And I'll just put it this way then. Because you only probably, do you need more than one?
I don't think so for washing.
Because you're,
Mix solutions.
because once, you just want to rinse it off each time before you mix, so you don't carry stuff from one cell to the next.
Yes, sir.
So that's what I would suggest.
It's tedious work.
Okay, well, with the most precipitate. What does that mean?
Like, what's that?
Like, is it foggy? Is that what it means? I don't know how to measure it.
Oh wow, it's like milky.
Wait, did I do that on your thing?
I think you did. You did it 5 on both sides.
Josh, you had one
Dang
drop.
it. I quit, I'm fired.
It's okay. Just put it in like the well in the middle. I
Have
guess.
the other thing on.
What was it? The
I don't know.
calcium nitrate?
It was
Sugar.
it was calcium nitrite and the one he's holding.
Yes.
Okay.
So
Take
now,
2.
so now I can actually put in my whiteboard that there's air in there.
Except that we're fixing the air.
How would you fix it?
this
Jack, do it.
5 to 10 minutes.
Josh screwed up.
Yeah.
Yeah, he screwed up. He did 5 and 5 and stuff like that.
One.
But yes, we're doing fine. Thank you for asking.
Okay. That was 2. Take 2. Or 3.
And then we have to reset a timer for that too. Now you start from 1 back.
Come on, Josh.
Okay.
Redemption. It's time for redemption.
So now I put 5 in. And
So
then
you put 5 in the first one. Yeah. Is that the same one that you did?
Do you only
Three.
throw into like sometimes I'm in the window.
going down.
Outside sometimes
4.
inside passing, outside
Like
passing.
mobile orders and stuff, like
Oh,
runners.
perfect.
Okay, now you set a timer.
Or new expo.
Do any of you have a phone?
Nope.
And not bring your phone.
Nope.
It's like where you
Okay.
There.
outside the drive-through and you
It's
Well-
done accurately.
Wait, so
So we'll do 7. So we'll do it. So it'll be 11, 11.
You call expo 10.
yeah, I think
Meeting one, other than that, I hate expo.
Okay, so now I can fill this out. A12.
You call expo
There was
the actual, with everything.
2, 3, 4, 5, and 1, 2, 3, 4, 5, right?
Yeah, that's the way.
Yeah, okay. From the 5 to the 4, 3, 2, 5 to 4.
Yeah, they scheduled me for lunch. I work like 10 hours. Really? I work.
Just for specific. I don't know. We should ask him probably.
Mr. Bruce,
Yes.
so what does our lab manual mean when it says well with the most precipitate?
I do 3 hours.
When it says what?
It says well with the most
I
precipitate.
do too. Well, actually,
Yeah, which well has more precipitation? See, because what do you expect in the chemical reaction to happen? And then you're gonna find somewhere in the middle that's gonna have the most precipitate, I would think, instead of at the end.
What is precipitate?
Precipitate, it's what falls out, you know, when you mix together, you get the stuff fall in the bottom, some solid form in the bottom.
Table 4. What's table 4?
Yeah. That's what it precipitates. It falls and precipitates to the bottom.
So there's solid stuff?
It has the chemical reactions there, guys.
So what do we put in the table? Do we just put the colors?
Pardon?
What do you put in the tables?
There's supposed to be solid stuff that grows and then puts it at the bottom. Okay.
Oh, you're right.
I don't see any yet, but
Or it has to sit.
we'll have to let it go 10 minutes. So,
Wow. Okay, so you put in A1 of the first one, we put 5.
okay, so I'm just gonna put it one more 10 minutes, so 10 minutes. That's 30 seconds.
We're supposed to write equations. How do we know what we created though?
What do you mean equations?
Well,
It says write equations for the reactions in part A and part B.
You do CuNO3 2 plus 5 Ki equals.
But we don't know what it equals.
You do.
Yeah, you do.
This is double replacement. Potassium and copper switch places. Copper tends to form 2 positive and the potassium forms 1.
Yes.
So you're going to end up with copper and nitrate just like that. And you're going to get potassium and copper and iodide with 2.
So that's what's gonna happen?
That's what's going to happen, so you got to balance
that's
it.
the equation.
See if it
Okay.
makes sense.
Yeah.
How much you balance.
So that means we'd have to put a 2 there, a 2 there, and that makes sense.
So relatively, which one has the most precipitous is what you're looking for. And if it makes sense what you did, and I know you're doing rough amounts, but it gives you an idea. Sorry, I'm cleaning up because they need me over there now. And I'm not gonna deal with it now. We have about 7 more minutes, I think, in class.
What time is it?
what?
It's 11
How long do we have? Is it?
11:40.
Oh, we have time, plenty of time.
I was gonna say.
So you guys tell me, is copper balanced both sides? How about nitrate? Is nitrate balanced?
So, wait, what?
Copper, one copper. Now you have 2 nitrates, SNO3.
So
How many nitrates?
we need to put a 2 there.
Oh, well, what does that tell me to do over
You
here?
gotta put a 2 there.
Oh, is that balanced iodine and balanced copper? It's balanced.
Awesome.
So you put in, so what do you expect? You expect to get the most precipitous, so you get a 2-to-1 ratio of potassium iodide to copper nitrate. I know you probably haven't learned how to pronounce these yet. So take and remember drops of each and see if it makes sense.
I don't see any solid stuff at the bottom
I
though.
don't need to do the second one.
You have 4 wells, right?
5.
See. So I'm just doing the one with the basic stuff. But then if you were to do it, then we'd have like 2 atoms or 2.
So how long do these have?
I'm putting them in for 2 more minutes. If it doesn't happen, I don't really know what to do.
This one looks
Fail.
like lemon lime Gatorade.
It
The other
does.
ones look like
Those look like sweet tea.
All right.
And this is
So
like
what did you start out with, copper nitrate, or which one was it more?
That's
Better
waste
check.
calcium nitrate.
I'm so confused.
I don't know what they equal.
I don't even know how to like for each one because we're supposed to try.
Okay, so you know that the reactants are going to be this plus this,
Yes.
but you don't know is what the
So
product.
then you're gonna repeat
I
it.
don't. Yeah, I don't know.
You're
what
gonna do this.
Okay, so now we
once.
have to see if there's stuff.
May know.
Okay, let me see if there's any other directions. So examine which is most precipitate. I don't see anything. Do you have to keep stirring for 10 minutes, or do
I
you just?
hope not. It didn't say anything about that. If I drop this on my eye, guys, y'all can have my stuff. I mean, it looks like there might be some solid stuff in the bottom.
I mean, but that might be the bottom of the well.
If the
Well,
precipitate
wait. There is some solid stuff. Hold on.
solid stuff.
That was really awkward. Okay, C. I think it's between C1 and B1.
All right.
I don't know.
So guys, we want twice as much potassium iodide as copper nitrate. Which one of these has that happen? Twice as much of this as this.
I'm sorry. Twice.
We want twice as much potassium iodide as copper nitrate. You're assuming one drop works. If it's the same molarity, then that would be true. So isn't this one the one that you have twice as much potassium iodide as copper nitrate? Expect to see the most precipitate here. That's
So
what you predict. That's the first one. And the second one, you have calcium nitrate. Instead, you have different compounds. So
So we would expect B1 to be the one correct. Yes. Okay.
the second one, you start from 1, 2, 3, 4, 5. I don't remember what the cells were.
Yo, I see solid
A1,
stuff at the
B1,
top.
yeah.
Do you see that?
That's,
Sure. Definitely.
and the little plastic
It's
thing
like
is a
salt.
stir. Now I would, have a little glass with a little bit of, you can pour into a little beaker the distilled water in that bottle next to right over there next to the cabinet, and rinse it off each time, and then do it so that you don't contaminate the cells. Doesn't take much when you have such small amounts. So you expect that, is this A1, B1, C1, etc.? So then in B1, you expect that to happen.
It looks like this by
For the second one, you do the balancing and you figure out some kind of table like this so you know what you expect. And if it doesn't happen, come up with why this will happen. Or
This one
close.
looks like the C well instead of B well has more. I don't know. There's a tiny something that looks solid. I'm going by. I'm trying to look for solid stuff. If I see something solid.
You know what? There's just about as much in B1 as C1. I think,
Okay.
I mean, I don't know what to
That
tell
could
you.
be true too, because I can see
Yeah.
that too.
So,
And then there's some stuff with D. There's like little stuff.
by the way, your
And this.
um,
You can see like little.
manual talks about excess. Well, no, in your worksheet, it talks about excess. They don't talk about excess reagent, they talk about limiting reagent. So if I need twice as much of this as this, when I'm here, I have more than twice this. So this is a limiting reagent, this is excess. Here it's the right amount of meat. Here, I need twice as much. So this is limiting, this is excess. And here it's even more so, this is limiting, this is excess. This is just right. Like Goldilocks, 3 bears, or 5 bears in this case.
Oh, is that what you're just putting like?
So, okay.
So in the second equation, which is I can't remember what it was.
I don't know for the second equation.
Yeah.
It's sodium
calcium.
oxalate and
Nitrate and sodium.
calcium nitrate. What does that mean?
Yeah, we don't know what that means.
It makes another snowflake.
That's the second part.
See, we have part wells that are messed up. Don't want to
No,
buy.
you're in 10.
Did you guys balance your first equation?
So what?
Yes.
Yeah, it's on the board, right?
Yeah, the first one's on, but the second one.
So the second equation,
Oh.
it's
No.
CaNO3.
Right, you gotta balance it, I'm not leaving it up to you, I did.
I don't see
But
much.
we don't.
Calcium does also have the same charge as copper as 2. You can tell when you look at the periodic table, you can see it's in column 2.
This looks like milk.
So it's got a, and nitrate is always -1, so it always takes 2 of these to bounce copper, just like it'll take 2 to bounce calcium. Potassium is in column 1, so it always needs 1, it always has a +1 charge, so it always be 1. And iodine is a halogen in column 7, it's 1 away from the end, so it always is -1. All the halogens are. You have your periodic table, right? You ought to hold those out so you can see. That helps you to balance the reaction.
So, what I'm confused at though is, I'm assuming that it's a double replacement equation, but I don't know which ones to replace with. So that's
It's always metal, it's almost always metal.
Yes.
These are metals on the left side. This is non-metal, and this is acting like it's 2 non-metals reacting together, it's a non-metal. It's always the metals exchanging places. You could say nitrates exchanging places. It was combined with copper, now it's combined with potassium, so you can see they're trading places. You got AB and CD, and it's becoming AB and BC. They're trading places.
CA.
And it's double replacement. How did yours come out?
So what is it equal to?
Oil?
Because I don't know which ones to replace.
No, man.
There's 5 different
You're
pairs.
supposed to know this stuff.
I guess the ratio?
Can you see that there's definitely more in B than C? In B, I can't tell, it's just there's not much there maybe. I can tell there's more in B and than C a lot more.
See, I can't see anything on that because it's all white.
Can you look straight down and see that there's
Oh
more?
yeah, there's more in B.
Almost about twice as much.
Ours
Theirs came out pretty well.
Maybe it's
No, ours has more
And
in
that's what we
D.
expected
And this one
because.
has more in D. That one, it does.
Yes, because you do with a balance that looks like this, so you expect to have, and assuming 1 drop of potassium iodide is the same molarity, if they're the same molarity, you have as many moles of this.
You know
1
what?
drop, you have moles of this and 1 drop. So you expect 2 to 1
I think C
ratio.
is larger.
So you start with 1, 2, 5, 5, 3, 2, 1, so here's where you get the right ratio, where all of it should react.
The C was larger
You
too.
shouldn't have anything left over. But what happens is, this is a precipitate. You have no way of knowing that yet. I know that nitrates always dissolve. They always dissolve. And potassium compounds, because they're in the first column, they always dissolve. So both of these, so this, because of potassium, it's going to dissolve. This, because of nitrate, is going to dissolve. When they switch places, potassium says, I'm always dissolving. It doesn't matter what I'm hooked up with. Nitrate says the same thing, but copper doesn't. It depends. And so this one ends up a precipitate. That's what you're getting, just FYI. I know you have no way, you don't have the background to know that yet, but that's how you can tell. The same kind of thing happens. Most calcium compounds dissolve, so calcium on both sides, that compound will be the one that dissolves. So it'll be the other compound for your second part, that'll be the precipitate.
So for our second thing, the white solution, is the solid, I can't tell if the solid stuff is even there or if it's on the bottom or the top, I think.
Did you do both? Did you do both of them?
Yeah, so this one was a mistake because we did the wrong kind, but this is the right one.
Looks like the fourth one doesn't have more. I don't
So
know.
I'm just, is it solid on the bottom?
It's on the bottom. It's on the bottom. You see, it's precipitate. It sinks to the bottom. It's precipitate. Falls to the bottom.
So it is going to be B4.
Yes. And what is the second one? It's calcium, nitrate, and
Calcium nitrate and the other
sodium
sodium oxalate.
oxalate.
So
Okay.
I'm gonna say
Sodium always dissolves. Huh. Calcium doesn't always, but it usually does.
The one that Mark
I just
just
put
marked
large.
which one.
All it asks
I
for
mean,
is
like-
the most, so I just put the most.
I
That's
can't
all
measure
I
them
put
out.
out for.
I just put small
Like, I'm not
amount.
trying to
But you had the most in ours and then each one.
You see, what they're doing the same kind of thing on the mole ratio on page 29, similar to what I was doing here. This is number of drops.
Yeah.
So,
So what I'm confused about is for the second equation, what is the product that comes out of the copper nitrate?
I'm gonna let you work on that. It's switching places, calcium and
Part
sodium
B was
switching places.
So
So you're gonna get calcium oxalate and sodium nitrate.
So calcium,
Yeah, and then
and then combine, and then another.
No. Calcium and sodium are both metals. The second part of a chemical equation is the
Oh, so.
non-metal. So it's calcium combines with
Oh, okay.
oxalate and sodium combines with nitrate.
Okay.
And you gotta, guys, you look at very carefully to find the ratio. So you know it's sodium oxalate, how many sodium does it take? Sodium like potassium is +1, calcium is +2. I think it's nitrate is again -1. And C2O4, it's called, is oxalate, is -2. So when sodium bonds have to be 2 of these to 1 of these. When calcium bonds, this will be 1 of these to 1 of these. I'm going to let you experiment, try to balance it. Next week you can look at it and see what you got. That's where the periodic table comes in handy. Mine's periodic table. Does anybody have a periodic table? Because mine's kind of tucked away.
I'm so.
Yeah, I don't care for theirs too much, but it'll work. Okay. So you notice potassium and sodium are column 1. They're going to have a +1 charge. It's always going to be, just need to gain 1 electron. This is in this column, calcium, so it needs 2. Copper can have a plus, where is it here? +1 or +2, it doesn't show it, but it can. And then here's iodine over here, so it needs to just gain 1 more electron. And you don't know about C2O4 oxalate, but nitrate is -1, oxalate is -2. So if you have, I think you have, you're going to have Na2C2O4, and you combined it with, was it calcium nitrate, I think? So it gave you this. What do you think is going to happen? You're going to have Na, you got, I'm not going to do it for you, and calcium. You can figure out how many it's going to be. Calcium can give up 2 electrons. Nitrate can accept 1, so it's going to take 2 of them. Oxalate can accept 2, so it takes 1. That's the reason we do to find, to balance it. That's why I use it with these formulas over here. So, calcium is like calcium is like copper in that in this case it has a charge of +2, where it gives up 2 electrons. Copper in some compounds gives up 1 electron, and some compounds gives up 2. Copper 1, copper 2, or cupric. Cupric is +2. So the similar idea, then you go back and look at your wells and figure out from the drops what you expect to happen. Just like we did here, we expected the second well to be the one that had the most precipitate. Because you had the right amounts of each. Now in the back, this has, I don't know if I have oxalate here, do I? See, I don't think that oxalate is not that common. I don't see it here at all. But the rest I don't see are here. And the charges of a lot of these. Because the ones in the middle here, this can be a problem because they can have more than 1 charge. So you guys already done both?
Yeah, we can include them now, I guess.
And I know it may be hard to tell, but if you look from the side, maybe you can see which one has the most specific. Try that. See in the side there, can you tell? Which, how high it is specifically?
Oh, yeah, you can see.
Why